This question asks us to do the question basically in two steps. It firstly asks us to differentiate this one using the chain rule. We know that's a good effective choice here because we've got brackets and a power, and it's too large to expand and you do it term by term. So the chain rule says to do the derivative of the outside, 5x squared plus 1 to the power 4, times the derivative of the inside, which is 2x. When we neaten that up, we get 10x, x squared plus 1 to the 4, and that's our answer. Then it says now use this to help us find the derivative of this piece using the product rule. Again, we just check that that's an effective choice of rule, and we think it is because we've got two things that are multiplied together, and this is power 5, so too large to expand. So to find the derivative using the product rule, we say it's the first times the derivative of the second, and we've already done that here, plus the second times the derivative of the first, which is just 1. So if I just rewrite this as it is without factorising just yet, now I can see that I've got x squared plus 1 to the 4th is a common factor. Leaves me with 10x squared there, and 1 lot of x squared plus 1 in the second piece. And there is my derivative. Question 7, part B, asks us first to differentiate 1 minus x squared to the power 4. Now this one I'm going to use the chain rule. I've got a bracket and a power. Chain rule says to do the derivative of the outside times the derivative of the inside. Neaten that up. Okay. And then it says, and then hence differentiate this piece. So now you can see that we've already done this component, and this will be our answer when we're ready for it. Just going to put a little line around here. So we want to do the first term times the derivative of the second, need to write the derivative there. The derivative was minus 8x 1 minus x squared cubed plus the second term times the derivative of the first, which is 6x squared. So I've got a bit messy in the corner there. I'm going to write it down the bottom. We've got minus 16x to the 4th factorise this, the highest common factor out of 6 and 16 is in fact 2. I've got an x squared, and I've also got 1 minus x squared cubed. That leaves me with minus 8x squared plus 3 1 minus x squareds. Minus 8 minus 3 is minus 11 plus 3. This is my final derivative piece. Let's just do one more in this set. Part C. says to differentiate y equals x squared plus x plus 1 to the power 3, and then use that to differentiate minus 2 lots of x squared plus x plus 1 cubed times x. I'm going to jump straight into this one here. Because I think we can when we use the product rule. So we're going to know my derivative is, let's call this the first piece, times the derivative of the second, plus the second, times the derivative of the first, and I've got to use the chain rule here. I've got minus 6 times the derivative of what's in the middle, which is 2x plus 1. Just tidy this up just a little bit. Becomes minus 6x times 2x plus 1 times x squared plus x plus 1 squared. So I'm going to take out a factor of minus 2 and two of these. Leaves me with one of those from here. 3x lots of 2x plus 1 from there. Expand this out. Collect like terms. There's our final answer.